Hello and welcome to the 19th and final video. Our what I call it is our wrap party. When I started this video series, I said I had the idea to do it because it's the summer of 2020 and all my plans were canceled as we were on lockdown. Well, since then, over the course of me making these videos, restrictions are lifted. Whether or not it was a good idea to do it at the time was a debatable issue, but whatever. And so I just thought I would sort of symbolize the sort of freeing up of things by doing this last video out back on my porch. Of course, I could have always done it on my back porch, but it's just sort of symbolic that kind of coming out, right? Maybe if I decide to do another video in a month or so, I'll shoot it on the sidewalk out in front of my house. Who knows? Drift ever further from that kitchen you guys saw me in. Also, don't forget, I invited you to go get yourself a treat yourself something nice, bring it to this video with me. I myself here have something called a Beanachino. It is the best drink in Dubuque and the largest size, of course. So if you forgot, go ahead, pause the video. I'll wait and get yourself something, and I'll be here when you're back. Okay, I'm assuming you're back. Knowing myself, I'm probably going to forget I even have this while I go off on a rant. But, well, we did it. 19 videos on, well, this is the 19th, the history and philosophy of mathematics. Hope you enjoyed it. I very much enjoyed making them, and I appreciated having your company through them. So what did I say I would do? I said I would start by talking about my very ignorant and uninformed view of what happened since Gödel's incompleteness theorem. Let's start with the philosophers. As I said before, the philosophers kind of went with Frege. They liked Frege. And one thing they liked about Frege was this. Remember how I said, you know, we can understand I have two pencils as really saying, I have one, there exists a pencil, there exists an X that's a pencil I have, there exists a Y that's a pencil I have, they're not equal to each other. Anything else that's a pencil I have is one of those two. And in that way, you can sort of analyze the meaning of that statement out to eliminate the word two. They were really enraptured with this idea of just analyzing what we mean by our phrases and our words in order to just make philosophical problems evaporate. Now, Frege still believed there were things called logical objects and numbers were objects, but people who were inspired by him and came after him liked the idea of just analyzing the number words out of our statements and eliminating the question of abstract objects altogether. And this gave birth to what we call analytic philosophy, as is reasons obvious. Cashing things out like that is analysis. So they thought they could solve all the philosophical questions just by doing careful analysis of how we use words. It went well with them for a while. It really took off in Europe and in England in the first half of the 20th century. Right before, leading up to, and during World War II, a lot of those philosophers fled Germany and the continent, for that matter, to America and to England. And so it eventually became known to some as Anglo-American philosophy. So if you want to do it location-based there, the other branch became known as continental philosophy. So there's the two big streams of philosophy, Anglo-American, which is analytic, and then continental, which some call interpretive philosophy. Those are the people that would definitely disagree with me when I talked about philosophy after Kant really being weird. Yeah, they would take offense at that. So sorry if you're one of those. And the interesting thing is, in America, there's a big strand of philosophy called pragmatism. So you may ask, what's the difference between an analytic and a pragmatic and a continental, right? Well, they would have different answers to the following question. So let me ask you this. So which of the following three people knows electricity best? A person who has a scientific training, who's never actually wired anything, but knows all about quantum theory and quantum electrodynamics. Analytics would say that is the person that knows electricity best. A person who actually wires house and works with electricity and has done a lot of stuff with it. The pragmatist would say that's the person that knows electricity best. Or the person who one day has no special training, has not worked with any wiring, but one day decides to take a metal butter knife and stick it into an outlet. The continentals would say that's the person that really knows electricity best. Maybe you can see the sort of three different strands of thought behind each of those things. Now, the reason I bring this up is because of the analytics in America, there's then this big mix of pragmatism and analytics. And eventually, there was a strong critique from inside this pragmatic analytic mix against analytics. And a lot of critiques against it. Eventually people were like, nah, maybe this doesn't really cure everything like we kind of hoped it would. And in my impressions, at least back in the 90s when I was in grad school, is that philosophy, the analytic tradition, which I kind of consider myself in, they seem to be trying to find themselves, if you will. There's still a great love of science and the desire that why are we doing all this philosophy if science answers the questions, is the way a lot of analytics look at it. So some want to answer just all philosophical questions using science. So for example, we have a question of, well, what are sets? If everything is sets in mathematics, what are sets? And some people would answer that by saying, well, we should just have a child developmental psychologist study how children develop their notion of collections, and that this should answer all our philosophical questions about what are sets. Therefore, doing it scientifically. Other people think, well, scientists have been really successful in the 20th century. They've done a lot of stuff. They must know something. So we should just look at what they're doing and take whatever they're doing as the answer to all of our questions about the philosophy of math. Speaking as a mathematician who knows some philosophy, that might not be the best idea. I mean, don't let me stop you from trying. And if you can make it work, all the more power to you. That's great. And probably we can get some insights by increasing communication between the philosophers and mathematicians. But some people, speaking as a mathematician, some people I think take that a little far. But that's kind of where it's at now. Now, what about mathematicians? Well, I've really played up in my last videos that after their infinitesimal problems were fixed, mathematicians kind of lost interest in philosophy, which I'll still stand by, which is kind of accurate. And there's also a large strand in, on that point too. Some mathematicians I've talked with might take offense to this and say, no, what are you talking about? At a conference, I was up all night at a cocktail party arguing philosophy. There's a difference between sitting up all night arguing philosophy at a cocktail party and being David Hilbert, right? Mathematicians don't see it as actually part of their job. It might be part of their recreation as much as they enjoy watching sports or something, but it's not part of the mathematician's job anymore. Nor is any interest in the history, even recent history. So here's the story. When I was in grad school, I had several different research projects I bounced around between. And at one point I was studying these things called the p-adics. P-adics are really cool. If you get ever chance to study them, I highly recommend it. I like them. I really learned a lot about them. If you know the p-adics, here's my take. P-adics are a really nice way for turning one really hard problem into infinitely many marginally easier problems. And sometimes that's what you need. So I went around the department, but they are really weird, really weird. So I went around the department asking people, why were the p-adics created? Why were they invented? And they kept directing me, oh, you should go talk to this person. He's our resident expert on the p-adics. We'll call him Professor X. So I went to Professor X and I said, why were the p-adics invented? And he said, oh, well, they're really great. And he starts telling me all these great things you can do with them. And I said, no, I know that, but why were they invented? And he said, well, and he started bringing up more things. You can do this, you can prove that, you blah, blah, blah. I said, no. Okay. At this point, I was served well by the fact that I had a friend in undergrad who was a big Blackadder fan, you know, Rowan Atkinson and the BBC and everything. And so a bit from there helped inform me how I could ask this question. And so I said, ages ago, people weren't talking about the p-adics at all. And nowadays, everybody's talking about the p-adics. There must have been a point in time at which the state of affairs in which nobody's talking about the p-adics went out of existence, and the state of affairs in which everybody's talking about the p-adics came into existence. Now, what I'd like to know is what happened in that state of affairs in which everyone not talking about the p-adics went out of existence and everyone talking about the p-adics came into existence. He didn't indicate that he got the reference. His answer was, quite honestly, I have no idea what that has to do with anything. The resident expert. And I think that's a very accurate reflection of the attitudes in mathematics towards the history of the subject, even a topic that you might be the resident expert on. Another story. I was at a conference talking with this a professor from France, Zoe. Great woman. And we were talking, and she knew my advisor, and talking about him. And she said, at some point, she said, and that's the point at which he came up with the definition of regular types. And I said, what? That was him? He did that? And she's like, oh, yeah, sure. You didn't know that? No, I didn't know that. You never talked about it. So it seems that this indifference towards the development and history of the subject goes even so recently in the past as, what your advisor themselves accomplished. There's just this developed idea through the history of science and in mathematics and all that these things are independent of history somehow, that they're just true out there, like statements that just come down from the sky, like from God. The statements of truths of mathematics and stuff, all the theorems, all the axioms, all that kind of stuff, and not that they're really developed by actual people in actual context. If you were in an art history class, or in an art class, I should say, you look at a piece of art and it was obviously created by a certain person at a point in time in a certain context. And you know what? Mathematics is developed in the same way. Any theorem you see, any result you see was developed by a certain person at a certain point in time in a certain context with a certain criteria of concerns they had and all of that stuff. But that seems to somehow degrade mathematics or science to some people, that it seems to rob it of its universal truth. And I think that's just all wrong-headed. I mean, mathematics is a human endeavor. It's done by people. And when you are a mathematician, you are part of a tradition. I think nowadays some people are trying to sort of get the hang of this and trying to get a feel for this. Some books are inserting sidebars of the history in their books, and I kind of find that a little disappointing. I mean, it's like the analogy of chocolate covering some broccoli. Like, the mathematics in the book is what's good for you. It's the broccoli. People are interested in history, so putting history in the sidebars is like covering the broccoli with chocolate to make it more palatable, to make it more tasty for people. They'll be more likely to consume it. They'd enjoy it a bit more. People love chocolate, and a lot of people might not like raw broccoli, let's say, but putting chocolate on the broccoli does not make it any more tasty. And, putting these little sidebars in chapters, oh, this is a history and stuff, it's just chocolate covering the broccoli. It's not actually presenting mathematics as coming out of a historical context and coming out of history. This is what I'm trying to accomplish in these videos, is to convince you that math really does develop as a human endeavor through historical contexts. I taught a class on modern algebra once, and every class period they had to read the next section in the book. And one of the reading questions they had was, what was the main point of this section? And it broke my heart. But, a couple weeks into the semester, I had to tell them, listen, I love history of math, but those historical sidebars are never the main point of the section. It breaks my heart to say this, but just stop it. It's not. And, why study this history of math like this is because if you're a mathematician, if you're in doing something mathematics, this is your story. If back in my video about Galileo, I didn't convince you then that I was talking about your people, if you recall what I'm talking about, maybe now, if you do mathematics, you're part of this community. My stories here talked about a lot of individual people, like this person, this person, this person. And what's lost in that is that they all operated in a community, even like Descartes, who, when science and research moved outside of the university system, he was writing letters to this monk named Mersenne about the stuff he was doing, and Mersenne was writing with other people, and when he got something good from Descartes, he'd make lots of copies of the letter and send it out to the other people, and they all wrote back and forth. Even at that point in time, math was always done in a community. Hilbert would not have happened if he was not a member of a mathematical community. He was an undergrad, he went to college, he was a professor at a university, and none of this would have happened if there wasn't a mathematical community. And this is the story of the mathematical community. And you yourself might be a member of the mathematical community, in which case these 19 lectures are a part of your story as well. Anyone who's doing mathematics, interested in mathematics, teaching mathematics is part of this. If you're looking for a little reassurance here, let me say this. Now, this doesn't characterize everyone that I consider part of the mathematical community, but if you have passed a class on real analysis, upper level undergraduate real analysis, you can consider these lectures as being part of your story. You can consider yourself as being part of the community, because real analysis is tough. It is hard. It is painful. If you got through that, consider these lectures to be about you too. And I think it's very important that we remember that. And it's very important for doing mathematics, getting mathematics done, getting people into mathematics, and just understanding the reality of the issue. It is a human endeavor. And this sort of notion that all of these theorems, we just present these theorems without talking about where they came from, as if they just, came down from above, distorts and does a disservice to the field. And it makes it a lot less appealing. Why would I, want to get into something? If you're a puzzle solver and you like solving puzzles and you see mathematics as interesting set of puzzles to go and crack at, and you want to make your reputation solving these puzzles, then you might be interested in getting into the field of mathematics. But the way it's presented, if you're just interested in being part of a community of people doing this long-standing endeavor, learning more, and if you're really interested in the topic, that might not be enough, given the way mathematics is usually presented. That's my take. And again, that's why I made these videos, is hopefully to start breaking out of that in a way that's a little more than just chocolate covering the broccoli. See, I told you I was going to go on a rant and forget I even had the Beanachino. I do wish we were here together so you could, respond to me. I feel like I'm just yelling at my computer in my backyard, but hey. Let's see. What else? Now, I'm not going to give a bibliography per se. I don't see these videos as being scholarly enough, rigorous enough to, spell out a bibliography. But I will talk a bit about some books that have influenced me greatly. Now, especially in this rant I just went off. If you've been watching these videos, and especially my previous rant, and you know a little bit about the history of science, you might completely expect this first book to come up. I've talked a lot about scientific revolutions, and I characterized the end of the 19th, beginning of the 20th century, when mathematics went about, being about truths to just being about implications, when these axioms imply these other theorems. I gave a talk about this once. I said it's when mathematics went from being about something to being about nothing, or at least nothing in particular. This is also the Russell quote of mathematics is the field in which we don't know what we're talking about, nor whether what we're saying is true. That whole transition I see as a scientific revolution in mathematics, just like we had the Copernican revolution, just like we have these other revolutions. Now, I've never seen anyone make that argument about mathematics, but if you're interested in this notion of revolutions, especially the thought that when we have a revolution going from, say, Descartes to Newton, that we don't just gain stuff, we lose stuff as well. And the decision to make that jump is not necessarily a rational one. It might just as much involve the old guard retiring or dying and the new guard coming in and replacing them. A book called The Structure of Scientific Revolutions by Thomas Kuhn. I would highly recommend it, and it has strongly influenced my view on science, and in particular mathematics, as a human endeavor, not always rational, something people do, subject to social forces, subject to human forces. I really appreciate that perspective, and it's developed very well in that book. If you were entertained at all by these videos and you kind of enjoyed it, and you're looking for, you never thought of the history of mathematics or philosophy of mathematics as being an entertaining endeavor, I got a couple recommendations for you. First of all, E.T. Bell's Men of Mathematics. Highly enjoyable, highly entertaining book. When I recommended it to my wife, I said, it's a history book. It doesn't always get the facts right. They're kind of warped a bit to make a good story, but when you read it, you won't care. And she said, I can't understand. How can you read a history book and not care if they're getting the facts right? And then she read it and she said, I understand it now. This is really entertaining. It's in addition to being a great book, it's what really got me interested in the history of mathematics in the first place. Like my freshman, sophomore year of college, I saw it in the bookstore and got it and loved it ever since. It's also inspired me. I hope that by making these videos entertaining, that you will excuse me for all the things I got wrong or glossed over or stuff like that. I hope that works. In the 90s, I went to a conference on the history of mathematics at University of Chicago. And at the conference, at one point, someone said, how many people in this audience got into their field, the history of mathematics, because of this book? And like half of the audience raised their hand. I mean, they all know it's not rigorous by the standards of rigor in their field, but they read this, enjoyed it, and they said, this is really awesome. Half of the people in the audience got into that field because of that book. And as far as getting into your field because of a book, I studied mathematical logic in both mathematics and philosophy. And what got me interested in that topic is this book, Godel, Escher, Bach, An Eternal Golden Braid by Douglas Hofstadter. And his main thing is to explain Hilbert's program and Godel's Incompleteness theorem. And he just brings in everything to try to explain it. A lot of the stuff you saw in these videos, I got out of that book. So for example, remember the Marguerite painting, This Is Not a Pipe? Way back when I was talking about the Greeks, I got that idea from this book. He was the one that first presented this whole idea of abstract objects and the problems of them in that way. In the David Hilbert and the Hilbert's program video, I think that was the previous one, the MI-MU puzzle. Can you get to MU from MI? He was the one that explained Hilbert's program in that way. So a lot of the things that I use to explain things, I got from that book. And in that book, every other chapter is a explanation, as you would expect, of things, but the off chapters are all parables. They're stories of various characters, Achilles and the tortoise, and characters he made up, the crab and the sloth, and all these animals, like Wind in the Willows, all these animal characters, and they're all acting out stories that somehow illustrate the philosophical principles that he's going to try to explain in the upcoming chapter. Really enjoyable, really creatively well explained, well reasoned out. A lot of any good explanations I had in this video series, I got from there. So those were 3 books that really strongly impacted the way I look at things and impacted my approach to this video series. And as far as talking about my influences in these videos, I would be remiss if I did not thank, of course, my advisor in philosophy, Mick Detlefson, for all of the stuff on Hilbert's problem or Hilbert's program and Godel's Incompleteness theorem. Patty Blanchette, who did a lot of scholarly work on the Hilbert-Frege debates. Obviously, that had a big impact on me and stuck with me. Also, Tim Bays at Notre Dame. He worked on model theory and nothing that got into this video, but honestly, it was actually my field, so I probably spent more time in his office than anyone else's. And still, like everyone else, he always made you read Frege and talk about that. And so I got stuff like that from him, so thank you very much. And at the time, when I was at Notre Dame, Michael Kramer was there doing work in Wittgenstein, so I learned my Wittgenstein from him. Again, something else that didn't get into these lectures, but had a big impact on me. And I would also like to thank my math faculty that helped me through grad school, especially Julia Knight. She's a great mentor. Peter Cholak, Sergei Strachenko, and my advisor, Steve Beekler. Thank you very much for all your help, and it's influenced me strongly and put a lot of stuff into these lectures. Well, I hope you got something out of them. I know I got something out of making them, and that's it. Have a good time. Thanks again.